Yeah. You guys
Jesse.
introduce yourselves, and then we have some people online that are also participating in
Hey, I'm Jesse. I'm with Orthogonal Research and Education Lab. There are a couple of our lab members here. Are like Aaron's on the phone, and Bradley is our director of science. So they're kind of telecommuting here. We're a distributed lab anyway, so it's actually pretty normal practice for us to meet asynchronously or synchronously here and meet up online. There's Bradley. There's Brian. Brian will be presenting live in like 20 minutes or so. So yeah, today, get to my this is our talk. Basically, when we mean frontiers in data privacy and ethics, we basically mean like some interesting things to be thinking about. We have some works in progress. We have some ideas we're doing in our lab, but a lot of things to keep in mind along this frontier of like data privacy and ethics and so on. Here's our lab. You can see the slide again later, but we're on Twitter and have different websites. We're on YouTube. We're distributed, open source, open science, and interdisciplinary. So basically, we believe in being open source, open data, and you'll hear more about that later too. We're distributed in that it's actually one of the rare meetings where like two of our lab members are in the same space. Brian and I are both. Brian's a current UAlbany student. I'm a former UAlbany student, and we happen to be able to both make this conference. So it's pretty cool. But we have people in like India, Europe, West Coast, East Coast. It's a really interesting setup. And it's interdisciplinary in that we cover a whole lot of things from like developmental biology, computational science, neuroscience, and I helped found the ethics and society team, which is kind of part of what this group is here. So for today, we're going to hear from Dr. Bradley Alicea, who you kind of saw briefly online. I recorded one of his videos. We're going to hear from Angela. We're going to hear from Brian. We're going to hear from Aaron. And we're going to hear from another one of our interns, Amaris. She couldn't make it, but I put together a slide with her that we'll talk about later. So yeah, this is kind of going to be our first foray into this. Will be Dr. Bradley Alicea is going to do a very broad overview of a project we're fleshing out, and also a Google Summer of Code potential application for it. So let's play that video.
Hello, I'm Bradley Alicea. I'm the head scientist and founder of Orthogonal Research and Education Lab. And I'm going to talk to you today about a project that we're sort of a formative project we're working on called a collective cognition model for ethical and sustainable open source. And so this is the Orthogonal Research and Education Laboratory. We're on the web, we're on social media, and we have a value of global and virtual connectivity. So if you're anywhere in the world, you can collaborate with us and participate in research. So what is ethical open source? So open source projects and organizations, and many of those you may be familiar with. These are like the Linux Foundation and some of the other foundations around the web, the Mozilla Foundation. They produce open source software. And some of these organizations are very big and some of them are very small. Despite their size, they rely upon contributors to maintain and sustain open software. So some of the bigger projects have solved the problem that I'm going to discuss with you, but a lot of the smaller organizations do not. And so that's where we're sort of aiming we're training our research chops to understand that. But also, for bigger organizations, this is useful because oftentimes they have a lot of people working on projects to maintain them, but it's very hard to get the mix of things right. So the recent security breaches in a lot of open source software have led to befuddlement by a lot of these organizations in terms of how they can keep up with the latest issues in security and other maintenance issues. So this is useful in a number of ways if you decide to work on this project. And two of the questions we're asking in this project are, how do you maintain a thriving community? So these open source organizations rely upon a community of contributors while keeping the community emergent and decentralized. We want to utilize computational models and simulation to provide a greater understanding of this process and how these social dynamics are maintained and can thrive. And then the second question is, can we identify some of these modes of regulation that might be reinforced within community standards and rules? So what can we do in terms of shaping that community that will improve its performance, improve its responsiveness, and so forth? So one of the ways we seek to do this, and this is, I'll get to at the end, I'll get to how this program is structured, or this research project is structured. The first solution are these homeostatic systems for open source sustainability. And so there are a number of ways that we can approach this. We've thought of approaching it through more of a cybernetical approach. So this is in the form of time-dependent block diagrams with arrows showing the relationships, the causal relationships, and the feedback relationships. So you can see on the right, you have this black box, and then it goes to a white box, and then it goes to a gray box. And if you join our group, you'll understand what those relationships are and what the meaning of those colors are. And we can, build these models that sort of represent things in the system, in social systems, but also in the technological system. And, we'll be able to implement this in code, hopefully, and then calibrate it with agent-based models, or real-world data. But it's hard to collect real-world data, so for now we'll be concentrating on agent-based models. The second way to do this is to use an approach like reinforcement learning. And so reinforcement learning is similar to this. You have policies that are selected, and that, we have behaviors that there's a feedback when you perform a certain behavior in a certain environment. And that behavior is sort of reinforced or it's discarded. And so that reinforcement learning approach is also very good for this. We want to find the best set of incentives in the reward structure of an RL algorithm. So we want to find social incentives, we want to find technological incentives. Another area you might look into if you're interested in this project is the ethical regulator. And this is sort of the inspiration for the work that we're doing. Something called the Evergood Regulator Theorem, which is something out of cybernetics. It goes back to the 1970s with Conant and Ashby. And it's basically the structure on the lower right where you have this variable and you have two parameters, S and R, and those are mapped to the space where you have G that fits inside of Z. And so G is the thing that you're trying to regulate, and Z is the thing that you're regulating. So this is your ability to regulate it. Z and G is the thing that you're trying to regulate. The idea is we want to have a good account of every possible state to be able to understand how to control G. So for example, if you want to enforce good virtuous behaviors, you have to understand the range of behaviors and the range of motivations that people engage in your community. It's not easy, but we might be able to do it if we have enough understanding of the system. So in the ethical regulator, this is this sort of idea of Evergood regulator but applied to ethics. And so up here on the top right, you can see this ethical regulator. There are a number of different aspects to it: purpose, ethics, truth, variety, predictability, variety being all the different states of a system. And this goes into an intelligence. And of course, these are black boxes. We can unpack these black boxes in the project if you would wish to do that. If not, we can still understand the relationships between these things. This leads to an ethically regulated system, and then a feedback to the ethical regulator in terms of awareness. So there are things like predicting future effects of actions, outcomes, a variety of possible actions, intelligence, choosing best actions, and ethics and truth. And so we want to do agent-based modeling to reinforce some of these things and find out more about what hypothetical communities might do. We can use a number of things in the NetLogo modeling software. There are a number of stock simulations that one can use: the tragedy of the commons, ethnocentrism, cooperation, and altruism. Those all come in within the NetLogo package. And an agent-based simulation is a computational model for simulating interactions between autonomous agents. So you can see here we have this grid where the cells turn different states depending on what their neighbors are doing or what the rules of the system are. And so we can model some of these scenarios in agent-based models and then get output data to train our model. We also might be interested in building some custom models of cultural evolution. So if you're interested if you have some background in programming and you're interested in cultural evolution, this might be a good thing for you to do. And this is an example maybe of how cultural evolution might work in the system. You have community standards, new ideas, and independent beliefs. These are replicators, so they're injecting new units into the world here, and then they're selected upon by some criterion, and so we can plot these out by sort of their behavioral state space. Finally, if you're interested in this, and this covers a lot of different potential topics, so contact us, contact Jesse Parent or myself. Also, if you're interested in if you can make the deadline, we are supporting a Google Summer of Code project. So this is getting paid for this sort of thing. And so you can find a formal description on Neurostar's GSOC Project 21.1 under the INCF banner. Thank you.
Cool. Great. So I think Bradley could hear your applause, so that's appreciated. We're going to jump right into, we're going to go through a bunch of presentations as fast as we can, and hopefully have time for questions at the end. You can also definitely reach out to us for any other questions that we don't get to.
Perfect. Okay, data trusts. So why data trust? So it is a structure whereby data is placed under the control of a board of trustees with a fiduciary, aka trust-related, responsibility to look after the interests of the beneficiaries, which would be us. There are many working definitions of data trust. Here are a few. The one that it doesn't particularly matter which one right now. They're mostly interchangeable. So the issue with mass data collection is that companies decide what to collect and for what purpose. The purpose is usually not to our best interest. Harms are collective, benefits private, and consequences are really hard for the average Joe to understand, if even the company understands it or has thought it out, right? Who gets to make decisions about our data? Usually a corporation, that's in quotes, for a certain reason. Like the director of a corporation has fiduciary responsibility to act in the interest of their shareholders. So the bottom line, their job is not to ensure your privacy or to make data available for the public good. I mean, those are, I'm sure they're not against any of that, but if it ever conflicts with the bottom line, their incentives are clearly to go for that, right? So there are several solutions to this. Maybe we could divorce those who wish to use the data from those who control its use, which is what personal data stores does, which it places the data with the internet user instead of the service provider. But the average user still wouldn't know what to do with that data, right? You would have decision fatigue, like, oh no, there's so many choices, analysis paralysis. And data is shared. So your sharing data affects me. So even if I decide like, okay, you know what, I'm going to be an isolationist island here, everyone else around me, it's gonna affect, like their data affects me. Yeah, if I am in that particular demographic or area, etc. And there is an enormous power imbalance between the corporations and the user, because Facebook's not gonna cry if you deactivate or delete for, like basically everyone is disposable, and that's really, really bad for bargaining power. Here is a nice and handy chart that I found, which tells you like, okay, which data governance structure is best for you? Has the data already been collected? Yes. Does this collected data give rise to personal rights? Yes. Then you can choose a bunch of these options. The one that I'm going to talk about is under the data commons one. And data commons is in which you basically put all the data from these public data sets to like an open knowledge repository. And a particular subset of that is called data trusts, in which like it allows for governance of these data commons. It allows individuals or groups to hand over their data or data rights to a board of trustees who will govern it on their behalf and on the behalf of the beneficiaries of the data trust. And how does this solve the mass data collection problems? So for your data privacy concerns, right now, when you share your DNA with 23andMe, it reveals a lot about your family's genetic makeup, and what you share on social media can influence your friends' insurance premiums. Your income statements can affect your neighbor's ability to obtain a loan. So should sharing this information be solely up to you? If it has such, massive widespread consequences. For social mobile applications, it's particularly dangerous because in a recent study, it showed that more than 60% of these VPN apps require dangerous permissions that are not needed for them to function, which pose a risk to users' privacy by allowing access to these sensitive information. And these are completely unnecessary permissions, but no one reads the terms and conditions, right? 90% of free apps on the Google Play Store share data with organizations. That's a lot. That's like the great majority. Yikes. The key elements of a data trust. So the first is that it has to meet all legal requirements, of course, including GDPR, the General Data Protection Regulations in Europe. They also need an accountable governing body to ensure that it achieves its stated purpose. Comprehensive data management, including clear processes responsible for these collection, and training and accountability requirements for all data users, and ongoing public and stakeholder engagement, basically dynamic consent. Okay, the 12 minimum specifications to make a data trust. The first is legal. The data trust has to be legal. The second, the government's portion of it, is the data trust must have a stated purpose. What values is it, is it supposed to fall under? And the data trust must be transparent in its activities. It must have an accountable governing body to hold it accountable, and it must be adaptive to the environment and the emerging tech environment that is very rapidly changing. Management. There must be well-defined policies and processes for the collection, storage, use, and disclosure of data. If it's ill-defined, that is a lot of data at stake. Policies and processes must include data protection safeguards, which are reviewed and updated regularly. Due to the speed of emerging tech these days, it has to be reviewed and updated regularly. So we have to design it to make it adaptable, basically. And like I said, there must be an ongoing process to identify, assess, and manage risks. Because at the end of the day, the goal is to make sure that people aren't hurt. The data user requirements. All data users must complete training before they access data, so they know exactly how to not screw this up, or if it's right for them. All data users must agree to a data user agreement that acknowledges that data use will be monitored and includes consequences for non-compliance. Right now, for most terms and services, people they agree to it, but how many read it? Probably none of you. If you do, props to you. But yeah, we need a way to have them actually understand, and that way that we will say there will be consequences for non-compliance, because they would not be the only person who is affected if something goes wrong. And public and stakeholder engagement. There must be early and ongoing engagement with stakeholders, including members of the public, especially the most disenfranchised. Where there is a reasonable expectation that specific subpopulations or groups would have a particular interest in or would be affected by an activity of the data trust, there must be direct engagement tailored for that subpopulation or group. So say the data trust is going to do something that's going to affect a certain subpopulation. Right now, there's nothing stopping companies from just making the action, right? But with a data trust, they would have to have some way to make sure that that group's voice is taken into account. Additional points of consideration that's not minimum specifications, but important to consider, is that we're international. So cross-border data trusts will need to identify multiple legal requirements and ensure that governance addresses all of them. The most obvious one I can think of is the General Data Protection Regulations for Europe. They have protections that free speech USA does not necessarily have. So if someone were to make a data trust in the US and want it to be international, they would have to consider like GDPR as well. Another point of consideration, there are binding terms and conditions in data sharing agreements between legal entities when data are shared. And last but not least, for research ethic boards and such, there will be project-specific requirements in those for obtaining consent from data subjects. Yeah. Here's a nice handy chart on everything that you could consider while making your data trust or designing it. Like, how would you fund it? How would you execute the organization? Because you could even have it be state-run. So the decision-making mechanism, you could have an aggregation of individual preferences, a voting of representatives, or a majority voting by beneficiaries.
Yeah, we just kind of that was actually the conclusion to that. Okay, so up next is Brian.
Okay, hi.
Whoops, and not me. But yeah, Brian, did you want to come up here?
Yep.
All right, I think your slides are, that's Aaron's? That's my old one. This is you.
Perfect.
Cool.
Thanks, Jesse.
You got it. I'm gonna probably sit here. Okay.
So ready. It's perfect. Hello, everybody. Thank you so much for coming. We've got a lot to talk about, and so we're going to talk really fast. And so thank you so much for bearing with us. Really quick, I just wanted to acknowledge that we're on Haudenosaunee and Kanankehaka and Abenaki land, because that's important. And also that I am a assigned male at birth person, and so thank you so much for having me here at the Celebration of Women. Yes. So I want to talk a little bit about interpretability. And I started by using an image synthesis model that I really love playing with because it's such a good example of like, how is this computer making these decisions? So in this case, the pre-trained model I'm using starts with this weird looking dog up in the upper left corner. And I asked it to think about artificial intelligence interpretability, and this is the image that it gave. That's strange. And then I asked it to draw an image of ethical artificial intelligence, and it came with this really creepy looking thing over there. I don't know what that is. So that's fine. And then I asked it to show artificial intelligence that we can trust and understand. And this I found really interesting because it started out kind of this nebulous, weird, creepy form, and then kind of became almost a human face as part of it. So how does this work? This particular image uses an implementation of what's called a big GAN, which pulls together a bunch of generative adversarial networks, best practices, and then scales them up. If you want to use this notebook, it's called the Big Sleep, and so you can look it up. It basically combines OpenAI's Clip and Big GAN to create images from text, and it's pretty simple actually in its conception. It basically encodes each pixel of the image with part of the text, and then draws on that data set when it synthesizes a new one. So it's pretty easy to explain, but the interpretation of it is different. So how do we interpret these images? If I had more time, maybe we could talk about that as a group. But since I don't, maybe I'll just move on. So I'm talking about interpretability, and I decided to focus on that and not explainability, because explainability is the extent to which feature values of an instance of a model are related to its model prediction in a way that humans understand. What does that mean? Basically, like, so for example, in this big GAN example that I started with, we can understand as humans pretty easily that each pixel is tied to a part of this text, right? Like, that's easy to explain. However, when we talk about the interpretability, how much we are able to consistently predict a model's results without trying to know these reasons behind that decision, that's a more tricky problem. So this talk is focused more on that. And this image is from NYCWiC, which is hilarious. I feel like this is me whenever I'm doing regression. Okay. So, when is interpretability important? And this is where the ethics really comes to the forefront of this issue. This guy, Christopher Molnar, has a pretty interesting book called Interpretable Machine Learning that kind of tries to guide people instances in which interpretability is not important. The first is if the model has no significant impact. So I imagine that means if you're just at home like me with this big GAN generating weird images out of text, no significant impact, that's fine. And the problem is well studied. So I think there's a few examples of this that we don't even consider AI anymore because they're so ingrained in the way that we use them. And then finally, if interpretability enables users to manipulate the system. This one threw a red flag for me. As a former union organizer, I was like, oh, hold on, wait a second. Because FICO, for example, I'm not sure if they're actually implementing it now, but they've definitely been exploring using AI to calculate credit ratings for a long time. They probably are using it. Shouldn't that be considered a significant impact on a human being? I think there's a lot of literature about this right now and related to mortgages and other things. This last criteria that he has seems to open the door to deep structural societal biases against all sorts of human beings. So moving on to the meat of my talk, I'm going to focus on two people that I ran into when I was researching this that I thought were very interesting and applicable to interpretability, Gary Marcus and Cynthia Rudin. I don't recommend following Gary on Twitter. Right now he's in a flame war with Jan LeCun, and it's getting pretty brutal. But his research is very fascinating. Starting with the algebraic mind, kind of has this idea about how to interpret neural networks using Boolean logic and the work of Claude Shannon and other people, which is really exciting if you're looking at deep learning models from a pragmatic perspective, saying, okay, we have these models, like, what are we going to do with them? How can we explain them? So there's a lot of explainable AI coming out that uses kind of some of these ideas, like Lime and others. So his early methodology, his main point, however, is that we don't have human AI level AI. We don't have generalizable understanding when we have a model that isn't cognitively sound, that isn't based on a deep, complex understanding of cognitive science. So in a lot of his work, he points to experiments on babies, not with these weird kind of machine experiments on babies, but more kind of seeing if you say like, okay, baby, like goo goo gaga, and then they say goo goo gaga, then you say, okay, tutu, and then they'll say tutu nata. It's like they are able to generalize based on patterns, whereas a lot of neural nets and the AIs that we have now, we're not really there yet. And I think that's a good point. It is one of his most recent books, Rebooting AI. He doesn't mention explainability or interpretability directly. However, as I was just kind of gesturing towards, it ends with this great quote, with the hope of a robust new form of AI, carefully engineered and equipped from the factory with values, common sense, and a deep understanding of the world. So that's one interesting way to move forward with this problem of interpretability, is to focus on cognitive models of how we understand the world and trying to imbue our machines and our systems with that understanding. So moving on to Cynthia Rudin, I highly recommend this paper, Stop Exploiting Black Box Machine Learning Models for High-Stakes Decisions and Use Interpretable Models instead. Rudin's work really lays out why black box models are not appropriate for high-stake decisions, like Compass AI, and there's lots of examples we've been talking about throughout this conference, which has been so great. The thing I find particularly interesting about her approach is that she recommends applying the data science methods that we already have at our disposal as scientists to develop our algorithms more carefully. And that leads to interpretable models that are understandable by humans and that are very clear. And often, she finds in her research that it leads to better results than deep learning networks that are black box. So it's pretty interesting. And here's another reason I didn't want to focus so much on explainable AI, which is that explanations are often not reliable and can be misleading. There's a few, like this kind of explainable AI image here from the Human-Centered AI Lab I thought was particularly illustrative of this problem. So I could just read these bullet points, but I won't because I want other people to be able to talk. Am I out of time?
Like a minute.
other thing about Rudin is that she tackles these proprietary models. A few years ago, ProPublica in particular released an expose kind of about Compass AI. And if you look up Rudin's work, you'll find that she has actually a much more data science-driven perspective on this problem and agrees with them, but kind of disagrees about exactly what the issue with Compass is. So that's a whole can of worms. And then Angela brought up GDPR. Rudin proposes that because right now GDPR, when it talks about explainable and interpretable AI, its language is very vague. So she proposes instead a possible mandate about something like GDPR that for certain high-stakes decisions, no black box should be deployed when there exists an interpretable model with the same level of performance. If such a mandate were deployed, organizations that produce and sell black box models could then be held accountable if an equally accurate, transparent model exists. So just to summarize, I started with image synthesis as a good example of AI which feels interpretable, but you're anthropomorphizing that AI when you talk about how to interpret that AI. And then we spoke about Gary Marcus and Cynthia Rudin and CARES. What I said about that. Great. And references. Weird pictures of pizza. All right, thank you, Brian. You're welcome.
So we're going to try to quickly go through our last step. I think you just heard Nick. So he's going to talk really quickly about some stuff. Do you want me to use the slides that you sent? Because I have them.
If you have them, that'd be great.
Okay. All right.
I'm having such a great time listening to these talks. Thank you all.
Okay. Okay, there's only, just so everybody knows who's listening, we only have like 13 minutes left. So, Nick, you have maybe like 5 to 7 minutes, if that's all right?
Great.
You can start when you
like.
like.
Okay, everyone.
I'm on your first slide right now. We can move to the next one.
Okay, great, thanks. Welcome, everyone, and I'm going to severely truncate this. If you'd like to see a lot of the key ideas, head over to our Medium in the next few weeks, and you'll see the updated sort of article that we post, and it'll include the sources too. So ethics and sociology and anthropology are the studies of ourselves. It doesn't make any rational sense to not include ourselves in the equation of our planning out where we go technologically. That's from tragicomic discounting of ourselves as factors. We're really instrumental in our endeavors. So using the Log4j incident, which you may have heard about recently, and its aftermath as a case for study, in the next few minutes, we'll all briefly examine it using the cultural anthropological lens laid out by Boyd and Richardson in their rich paper, Culture and the Evolution of Human Cooperation. And in so doing, we'll investigate together the importance of our species' continued collaboration on open tech endeavors and the commensurate challenges and opportunities of such a commitment. Open tech refers to systems making use of electric circuits, hardware, and software, which we construct and gift to the other people of our species to use in further fashion in their own activities. The tech can then be used in various scenarios and improved upon or differentiated, multiplying the actualized facility of the tools. This sharing of our tools has been a key method of our species development, a more causative factor in the rapidity of our adaptive strides compared to other species. It's now proposed than even our ability to solve alone. So, we've had that idea of like, oh, we had bigger brains develop, and it's actually considered our ability to share our tools now that led to this, vast development. So for a quick background for you, we know Darwinism is used as a great model for looking at what happens with us biologically. Darwin has some ideas about what happens with people ethically as well, which you might really love to dig into on your own time. Social Darwinism, unfortunately, came about when other people ignored what Darwin's ideas were about how we treat each other and how that would all play out. And instead, they ineptly misappropriated his tools for biology and a biology-appropriate model of evolution. And they misappropriated them, misapplied them to the sphere of people's interactions with other variables they didn't really think about well, like will, human will, freedom, learning, culture. And social Darwinism is a debunked idea often used in the service of racism and sexism. And you'll still see it around you despite it being debunked. For a quick quote, I'll refer to. Sorry?
Did you want me to stay on the first slide or just go to the second one, or does it matter?
Oh yeah, go ahead and go to the second slide. It's just a really, it's just there if you have something to look at, basically. We'll have more visuals on the Medium later on.
Okay, I'll just keep it here then. Yeah, but
Okay.
you have like a couple minutes, so.
Okay, great. So I'll wrap up. Rushkoff, Boyd, Richardson looked at a dynamic that emphasizes, quote, dynamic that emphasizes it's been the more empowering information sharing through the cooperative power of humanity, not some social Darwinian personal victory over the other, which has most catapulted human evolution. And then a quote within that: we used to believe that human beings developed larger brains than chimpanzees in order to do spatial mapping of our environment or to make more advanced tools and weapons. From a simplistic survival of the fittest perspective, this makes sense. Ellipses. But it turns out there are only slight genetic variations between hominids and chimpanzees, and they relate almost exclusively to the number of neurons that our brains are allowed to make. It's not a qualitative difference, but a quantitative one. The most direct benefit of more neurons and connections in our brains is an increase in the size of the social networks we can form. Complicated brains make for more complex societies. End quote. And I will wrap up and conclude. I'm going to skip the beef of this paper, and please check it out later. I'd also love to hear where you get with OpenText yourself, so please reach out to Jesse for that and let us know where you're at. I'm going to scoot down further and talk about MIT Technology Review. They recently put out an article interviewing Driggs, a, quote, machine learning researcher at the University of Cambridge, end quote, about the failures so far in attempting to harness AI against the selective assailant COVID-19. Quote, the simplest move would be for AI teams to collaborate more with clinicians, said Driggs. Researchers also need to share their models and disclose how they were trained so that others can test them and build on them. Direct quote, those are two things we could do today, he said, and they would solve maybe 50% of the issues that we identified. End direct quote. Getting hold of data would also be easier if formats were standardized, says the Logman team, a doctor who leads the clinical technology team at the Wellcome Trust, a global health research charity based in London. And another problem Wyness, Driggs, and the team all identify is that most researchers rush to develop their own models rather than working together or improving existing ones. The result was that the collective efforts of researchers around the world produced hundreds of mediocre tools rather than a handful of properly trained and tested ones. Direct quote, the models are so similar, they almost all use the same techniques with minor tweaks, the same inputs, and they all make the same mistakes, says Wyness. If all these people making new models instead of tested models that were already available, maybe we'd have something that could really help in the clinic by now, end direct quote. And I'll scoot further down in the quote. To address this issue, the World Health Organization is considering an emergency data sharing contract that would kick in during international health crises. It would let researchers move data across borders more easily, says Mateen. Before the G7 summit in the UK in June at that time, leading scientific groups from participating nations also called for, quote, data readiness, end quote, in preparation for future health emergencies. Please go ahead and check out the Medium for the rest of this. I'm really interested in the topic. I'd love to hear more from you. To sum up, I and others advocate that government and corporations and individual developers invest in OpenText because it, like the ocean, actually can lift all boats. You can start your own collaborations on OpenText, advocate that the businesses you work at set aside financial support or in-kind donation of programming skills for the updating of projects that it uses. Businesses used the Log4j tool, but they weren't patching together and contributing in its upkeep, and we weren't able to locate the challenge that it provides and the sort of backdoor. And if a lot of our tech companies and developers had all been contributing to the quote-unquote commons, we might have found it earlier, tested it all, and continued. And there's a movement now of people suggesting we should move away from OpenText rather than let's contribute, put in our efforts, and say, you can put down your load, let's contribute, and all of us take a part of this instead of just a few key players trying in their free time to do it. We can all be benefiting from OpenText, including private businesses, and then also those private businesses and others can be contributing to OpenText. Thank you very much, and look at our media blog for future postings of sources for this talk.
Okay, thank you. Thank you, Nick. All right, so really quickly, we have like 5 minutes left. Yeah. So I'm just going to quickly go over the final part of our talk. You kind of can see this here. We did all this stuff great. Angelo Data Trust, Ryan, Amaris, and myself worked on this. How many people know about Tim Najibru? Anyone heard of her? Cool, great. But basically, she was on Google's AI ethics board, and December 2nd, I believe, 2020, she was fired, or she resigned, depending on who you ask. So Amaris helped put together some of these key, general points. But I would mention, we actually talked about this a little bit last year, because last conference was kind of in the wake of what happened at Google. And we had, she was fired, and this is her coming out on Twitter about that, and the major backlash happened. Who is Tim Najibru? She is a leading ethics researcher. She deals with biases and harm that come from AI. The paper of question was, and you can't really see that well, but oh no, it doesn't have her name. They kind of use pseudonyms on some of these things, but this was a paper submitted in their IPS, which is a major computing conference, and Google had they professed that it didn't go through their system of vetting properly, but there was a lot of contention about what happened, and maybe they didn't like the paper because they criticized a lot of their efforts to use deep learning and for natural language processing in a certain way. Google maybe said, "Oh, you're only talking about the problems and not the solutions, so maybe you didn't do it right." But it was also just very critical of what they're doing. Stochastic parrots is kind of are we creating these things that, oh, it's a parrot, it's like a parrot, it can say words, but does it know what it's saying? This is kind of the example she's using in that context. So she's kind of criticizing Google a little bit, and Google didn't like that. So there was a major backlash. There was a Google, there was a walkout. There was a lot of people who were like, okay, a lot of AI ethics stuff is just for show, and a lot of criticism came from that. I'm going to skip some of this, just going to get to the conclusion and have a few minutes for questions. Recently she founded the DAR Institute, DARE, Distributed AI Research Institute. This is some of the goals. This is current research projects. I also happen to sit in on a discussion at MIT's AI ethics reading groups. I'm not with MIT, but I'm in part of their ethics discussions in Boston. There I am, and there she is. It's really cool. So she actually is going through some of her talk. A year later, she basically founded Distributed AI Research to kind of have her own research institute. And she really wants to emphasize specific values we kind of alluded to earlier in our talk, but about distributed communities that are embedded in their area, environments where we conduct them, prioritizing the well-being of the researchers, giving them space to do their work without cramping them with certain objectives or whatever else. And maybe AI isn't the solution sometimes. And that's important to keep in mind when you're trying to advocate for people as opposed to just a technological solution you have available to. Some of the things here about, really great criticism or commentary from Karen Howe. What problems are there? How can technology be used to redistribute power and equity in situations, or can it not do that? Some other examples, this recent one she's doing. Some other great tech ethics to mention: Ruha Benjamin, Abeba Birhane, Margaret Mitchell, Sarah M. Brown, Ramon Amaro are all great people. Check them out. And then finally, just to mention our whole crew: Bradley, Angela, Brian, Nick, Aaron, Amaris, Jesse, myself. And then our alumni: Min, Shruti, Krishna, Valeria, and Ankit, Amanda, Avery, Daniela, Jenny, Rashad, Sadhna, Samantha, and Shaima are other interns in Albany. So thank you so much. I know we don't have much time, but I'm ready to take any questions in the few minutes we have left. Thank you. Any immediate questions? I know there's a lot on a lot of different things. Brian had a great person call. Hey, sure.
Can you give an example of how non-technical systems could damage society?
I think that there's a lot of examples. So the first one that comes to mind is Compass, that it's being used actively to decide who gets parole and what the possibilities of recidivism are. Like basically that the prisoner will end up back in prison or will commit crimes again. And looking at that data, Rudin and other researchers have found that a lot of times someone, to a human, it would be like, okay, this person is obviously going to go, like it's like somebody with like 20 felonies, and they're like gonna get hit. But the system will mark them very low because of the color of their skin, for example. have only committed minor crimes will be ranked very high.
Sorry.
So that's one example, but there's a lot. There's a lot. And,
Yeah.
and that the legal parts of this are still developing. That's something I wanted to talk about during the talk, but didn't really get into. But if you look into the legal literature, people are starting to tackle this in a really concrete way, and it's very exciting.
Yeah. Look at like AI bias and like hiring, even a lot of other things that are just allocating people to resources. There's a lot of issues there. But any other questions? I know kind of at time, so I could maybe do one more, but I gotta go. Okay. Well, thank you all for your attention. And if you have any questions, please email me or talk to me. And if you have anyone ask any of our individual people, like Nick or Bradley or Angela, I can get you to them. So thank you so much.